Everyone, myself Professor Santosh Shiro, working as Assistant Professor in Chemistry of Engineering and Technology, Vijaypur. This is the video lecture on operational amplifier parameters. Okay, so this lecture series is mainly focused on VTU students who are studying in first year. Okay, we are as for our syllabus, we have certain parameters to discuss. The first parameter to discuss is input offset voltage. Okay, so what is the input offset voltage? Just see, whenever both the input terminals of op amp are grounded, right, we have two input terminals. When both the input terminals are grounded, the practical op amp shows a small non-zero output voltage. Okay, and this is due to mismatching of the present internal circuit of an op amp. Such an voltage can cause error in the practical applications for which the op amp is used. Now, this is not an acceptable case. So what we have to do is you have to remove that small output voltage that is coming. So that is what he is saying. To make such voltage zero, it is necessary to apply a small difference voltage between the two input terminals of an op amp. This voltage is called as input offset voltage. Okay, let us try to define it. So, the differential voltage that must be applied between the two input terminals of an op amp to make the output voltage zero is called as input offset voltage, and usually we denote it by VIOS. Okay, so this is the input offset voltage. In order to elaborate this, he has given the some figures over here. You can see in the figure A, we have op amp 741 IC, and here we have connected both the input terminals to ground. Okay, even though we have connected both the input terminals to ground, output is showing some voltage over here. You can see the meter, and meter is not at the zero, it is showing some voltage. The meaning is some output voltage is coming in. Okay, now in order to make this output voltage zero, what we have to do is, as it's showing in the figure number B over here, in which the output voltage is zero, how we have made it zero is by providing the input voltages over here at the two input terminals VDC1 and VDC2. By giving these appropriate voltages between VDS1 and VDS2, then we make the output voltage zero. Okay, and VIOS, that is input offset voltage, is given by, it is a difference of VDC1 and VDC. This is all about input offset voltage. Now, second parameter to be discussed is input offset current. Okay, now see, input offset current, here the input stage of op amp is a dual input differential amplifier, and the input terminals are the base terminal of the two transistors. Okay, so you'll be having the two transistors over here, and both the bases of the two transistors are given to both the inputs of op amp. Hence, the input currents of op amp are base currents of two transistors Q1 and Q2. Ideally speaking, this Q1 and Q2 must be perfectly matched. At the two cases, two base currents must be equal. Both the base current must be equal, but practically the input base current differs by a small amount. Fine. The algebraic difference between the two currents flowing into the two input terminals of op amp is called as input offset current. I repeat, the algebraic difference between the currents flowing into two input terminals of op amp is called as input offset current, and we denote it by IIOS, and mathematically we write it as IIOS is equal to modulus of B1 minus of B2, where IB1 minus IB2. What is IB1? It is the current entering into the non-inverting input terminal. IB2 is the current entering into the inverting terminal. Okay, ideally IBOS is 0, while the op amp 741 IC is having a maximum value of IOS, that is nearly around 200 nano amperes. Fine. This completes the second parameter. The next parameter is input bias current. Okay, input bias current. The average value of the two input currents flowing into the op amp, that is input terminals, is called as input bias current and is denoted by IB. In the previous parameter, we have discussed the current that is entering into non-inverting terminal is IB2 and inverting terminal is IB1. If you add them together and take average of that, that will be giving you input bias current is equal to IB1 plus IB2 divided by 2. Ideally, it should be 0. The input bias current should be 0, and but a maximum value of IB will be around 500 nano amperes. This completes this parameter. Let us go to the next parameter. This is CMRR. CMRR stands for common mode rejection ratio. CMRR is the common mode rejection ratio. So it is the ratio of differential gain AD to the common mode gain AC. I repeat, it is the ratio of differential gain AD to the common mode voltage gain AC, and mathematically we write it as CMRR is equal to AD divided by AC. Okay, the CMRR is generally specified for the op-amp and is expressed in terms of dB, that is decibels, and for op-amp 741 IC it should be 90 dB. Now, higher the value of CMRR, the meaning is whatever the maximum possible higher value CMRR we have, then better is the ability of op-amp to reject the common mode signal. The meaning is uh, if CMRR is higher, then we say that such a op-amp is having a better ability of to reject the common mode signal. This is the CMRR. Next, we have the parameter input impedance. It is also called as differential input resistance of op-amp. Let us define it. It is the equivalent resistance measured either at the inverting terminal or at the non-inverting input terminal with the other input terminal grounded. And it is denoted as RI. I repeat it. It is the equivalent resistance measured either at the inverting terminal or at the non-inverting input terminal with the other input terminal grounded. For example, if you are measuring the input impedance at inverting terminal, then non-inverting terminal has to be grounded. Or if you are measuring the input impedance at non-inverting terminal, then inverting terminal has to be grounded. This is the case, right? It is noted as Ri, and ideally it should be infinite. For the op-amp 741 I see it is of the order of around 2 mega ohms, right? Next parameter is output impedance. It is also called as output resistance of op-amp. Let us define it. It is the equivalent resistance measured between the output terminal of op-amp and the ground. I repeat, it is the equivalent resistance measured between the output terminal of the op-amp and the ground, and its value must be as low as possible. And for a op-amp 741 IC, it is around 75 ohms. Next parameter we have is slew rate. Okay, the slew rate is defined as the maximum rate of change of output voltage with respect to time. I repeat, it is defined as the maximum rate of change of output voltage with respect to time. The slew rate is usually specified in volts per microseconds. Mathematically, we can write it as slew rate. We denote it by S, which is equal to d by dt of V naught. Okay, with respect to time variation in output voltage we are measuring. Okay, and slew rate is caused due to limited charging rate of compensating capacitor and the current limiting and saturation of internal stages of op-amp when a high frequency large amplitude signal is applied. And for op-amp 741 IC, the slew rate is around 0.5 microseconds. Okay, ideally it should be infinite. The slew rate should be infinite. Higher the value of S, better is the performance of op-amp. Okay, so this completes the op-amp parameters parts. Thank you.